Okay, so the math dealer here, and today this is going to be a little video for all you Algebra 2 students that are trying to figure out how to graph an absolute value function, right? So oftentimes we sit there and we look at the H and the K's and we're like, what are they talking about? So for starters, just remember this. Absolute value functions will always take this form of an A, some number, times the absolute value. Those are absolute values. Those are not L's. X minus H, right? Plus K. Now, when you are given the vertex of an absolute value function, very cool fact, you're given the H and you're given the K. So immediately label H and K. In this case, I even gave you A was 2. So if that's the case and all you're trying to do is find the function, you're literally just going to plug in what you know. F of x is equal to your A, absolute value of x minus a minus 3. Okay, making sure that's a little bit neat if possible, right? Plus k. In this case, k is 1. Now, when you clean this up a little bit, you all know that minus a minus is a plus. You learned that back in like 7th grade, okay? So there you go. You have f of x is equal to 2 times the absolute value of x plus 3 plus 1. This is the function whose vertex is negative 3 comma 1 and whose a is 2. Now, I do want to point something out. Look at what happened. When I plugged in my h, I had to take the opposite of it. I tell you that because oftentimes you're given this function and they're asking you to find the vertex. So just remember, when you take the h out, it has to go opposite, but the k stays the same. All right, so pause the video if you have to, rewind it if you have to, do what you have to do. That's the beauty of these whole videos, right? You can rewind. So now, check this one out. First thing, it says, find the vertex in the axis of symmetry. Okay, well now, here's my function. I'm going to blow it up over here. F of x equals negative 2, absolute value of x minus 3 plus 4. So the vertex, again, like we just said in the earlier thing, the vertex is h and k. Well, H and K come from, you got to actually find H and K. I always laugh when students tell me the vertex is H and K, and I'm like, no, give me a value. Hello, give me a value. So f of x is equal to A x minus the h plus the k. So like I said in the earlier thing, my h is a positive 3 because the only way I was going to preserve that minus is if my h was a positive 3. And k, of course, is just a 4. It's exactly what you see. So my vertex here is a positive 3 comma 4. The axis of symmetry, and maybe I didn't mention this earlier, but I did in my class. Axis of symmetry is x equals whatever your h is. So whatever the h value is, that's what it is. And it's a vertical line. So the axis of symmetry is a vertical line that goes right down the vertex. Okay, it's a vertical line through the vertex. Well, we learned in one video, right? Vertical lines are always named by their x coordinate. So it's a vertical line through the vertex. So since it's a vertical line through the vertex, it's got to be x equals 3. Okay, so hopefully right now you're looking at this going, okay, I see what she means, right? Math dealer's got this, my H and my K, I'm good to go. Now, let's jazz it up. I know, right? What the heck? Now, these are the kind of questions I'm used to in my honors algebra 2, right? So if I give you a function, let's say I give you the following function, negative 3, absolute value of x plus 1, I don't know, plus 6. Fair enough? All right, so we're going to find everything there is. So pause the video, jot it down, get ready to go. All right, here we go. First and foremost, find the h, find the k. So my vertex in this case is going to be negative 1 comma 6 because, again, it's x minus what? And that what is where I'm going to get this positive 1 from. So x minus a minus gives me the plus, all right? So my vertex is negative 1 comma 6. Axis of symmetry. We said that earlier, right? It's a vertical line through the vertex. So it has to be x equals negative 1. Fun fact about absolute value functions. The domain will always be all reals as long as it's not restricted, and it's not. The range, however, is a little trickier. Let me talk about how to get that range. So for starters, I'm going to sketch this graph, right? So I'm going to graph this whole thing. The first thing I'm going to do is I'm going to plot the vertex. That's really your first attack when you're trying to graph these absolute values. Find the vertex and plot it. -1, 6 obviously is over in quadrant 2. So I'm going over 1 and then up 6. 1, 2, 3, 4, 5, 6. Right? Look at that. Right there. So exciting. Then what I oftentimes tell my students to do is to go ahead and draw in the axis of symmetry. That's my vertical line and it's my fold line. Now, very simply, find a value that's next to my vertex. In other words, plug a value in for x near my vertex. So I'm going to plug 0 in. So I'm literally going to go find f of 0. F of 0, here we go. Plug the 0 in and do a little shimmy, shimmy, work. You can do this. Absolute value of 1 is 1. -3 plus 6, oh, by the way, is 3. So when I plug in 0, I get 3. So 0, comma 3. There you go. Now check it out. If I go 1 to the right, 1 to the left gets me that mirrored point. So the other point would be -2, comma 3. All right, that's what that mirrored point is. And that mirrored point comes over the axis of symmetry. So my graph is actually opening down. So then the range, by the way, is opening down. So my range is going to be all y's that are less than or equal to my k. All right, and us Honors Algebra 2 crew, we do it in -infinity up to 6. But if you don't want interval notation, because this is to everybody, then you can always do it with the inequalities. And it's opening down. Fair enough? Hey, check out what we just found. We found our Y-intercept, didn't we? Y-intercept, to find a Y-intercept, we always set x equal to 0 and solve for y. So I don't have to worry about finding that now. X-intercepts I will have to go find. Okay, so my x-intercepts, by the way, I'm going to set the y equal to 0 and solve for x. So here we go. We're going to set the y equal to 0 and we're going to solve for x. So to find an x-intercept, maybe I should do a video on that alone. Always set y equal to 0 and solve for x. So when I solve for x here, I subtract 6 from both sides. Super exciting. -6 equals -3, absolute value of x plus 1, right? Remember, to solve an absolute value equation, you have to isolate the absolute value. So I'm going to divide by -3. I get 2 equals the absolute value of x plus 1. Now, whenever you're solving an absolute value equation, you need 2, right? You got to have 2. So I'm setting up x plus 1 equals 2 and x plus 1 equals -2. So x is equal to 1 and then x equal to -3. Those are my two x-intercepts. So my x-intercepts, what did I just say? It was -1. Sorry about that. No, it was +1. Look, I'm messing it up already. My x-intercepts are +1 and -3. Okay, so to kind of wrap it all up, all right, I know that I went super fast, but that's the beauty of these good old videos. You can pause them and rewind them, I know, right? Super excited. So just to sum it all up, right? All absolute value functions will take the form of a, absolute value of x minus h plus k. And there are ways of getting the a to pop out, but we're not going to worry about him right now. The vertex is always h and k. Of axis symmetry is the fold line through the vertex, and it's a vertical line. Now, when A is positive, the range is actually k to infinity. And if you write it in the inequality form, it looks like that. If A is negative, then it's less than or equal to k. Domain is always all reals. You'll never get that wrong. X-intercepts, make sure you set, if they have any, set y equal to 0 and solve for x. And in order to solve for x, be sure to isolate the absolute value and create two equations. And then create the two equations. I think a lot of students mess that up. And then, of course, the y-intercept, you set x equal to 0 and you shimmy, shimmy, work, and you get out a value for y. All right, I know this was a long video, but I really hope it was helpful. This is the Math Dealer signing out.